Hey everybody, welcome back to the channel. Okay, today we are going over Palantir's Apollo software offering. They have three main softwares. I know I just put up 3 fingers, so that's 6, but it's 3. Foundry, Gotham, and Apollo. Now, the video I just uploaded before this was likely on Gotham, and it gave you a better understanding of defense decision-making. Gotham is, and check that video out if you haven't, because it's a really cool video that we reacted to on their website, which is a governmental software, primarily for governments to defend themselves in times of need. This is Apollo. A little bit different. This is about things like submarines and satellites and stuff that's a little bit more out there, and that's the nature of why Palantir could possibly become one of the most important software technology companies in the world, because it's doing stuff that really is out there. So we're going to analyze this video today. It's on the website. It's about 5 minutes. We're going to react to it, and we're going to really try to understand, again, if you're a shareholder in this company, what is the core software that they offer. And again, if you are a shareholder in this company, I think you should know this stuff. This is something that I am trying to do in terms of my due diligence with any company that I buy, is really understand what the heck are they trying to sell, right? And understanding their software, understanding their core offerings, especially if you're in a technology company with a company that has very high multiples, you want to understand why you're paying 18, 19 bucks a share. For what in the future are you going to get from paying that money? So today we're going to react to Apollo. We're going to try to understand it, and then we're going to try to interpret why that will give Palantir a growth trajectory that allows it to grow into its market cap and eventually hopefully expand its total addressable market. So let's get into it.
I'm Greg Diarmid, Group Engineering Lead at Palantir, and today I'll be discussing Apollo, Palantir's platform for continuous deployment across all environments. We built Apollo to bring the convenience and stability of SaaS where no SaaS has gone before. From submarines to satellites, private clouds, and on-premise data centers, Apollo enables the secure, seamless delivery of software across any environment, anywhere on Earth. This flexibility enables us to meet our partners where they are, wherever they are, and in turn empowers them to reach further. When we launched Gotham in 2008, cloud computing was in its infancy. Most enterprise software was still installed in customer-owned hardware in their own data centers, meaning upgrades were relatively infrequent and manual. By the time we launched Foundry 8 years later in 2016, the software landscape had changed dramatically. The cloud was discussed as a singular entity with a singular grip on enterprise software. Companies rapidly embraced the SaaS model, microservice architecture, and CI/CD for the ability to push constant, granular updates to their production environment.
Okay, so what he's saying here is that in 2008, companies hosted their data internally, which meant the ability for their customers to get updates on their products was infrequent because companies didn't have control to be able to send over-the-air updates. What happened in 2000, I would say around 12, 13, with the rise of Amazon Web Services, and then you had Google Cloud, Microsoft Azure, AWS obviously being the big one. I think it brought in about like $17 billion of revenue for Amazon this year. It's just like a money printing machine, is cloud computing, where now companies, nonprofits, organizations, anything that hosts a lot of data, you're talking about pictures, images. I actually have a startup, and it's an audio startup. We host a lot of audio files. That all needs to be stored somewhere that is integrated within the company, but it's in a centralized place where you don't have to worry about it. So instead of stacking up servers, you kind of just connect to AWS. You pay them like $100 a month for us, right? But obviously other companies are paying like millions of dollars a month. Some companies billions of dollars a month for all of that stuff to just be there and to not worry about it. And now when you give updates to your software, when you try to get your software to be at the highest of levels for all your customers, it's as simple as like pushing a button and that stuff goes to Amazon, and then or AWS, whatever you're using, and Amazon sends that out to all your customers, right? So cloud computing over the past 8 years has really become a revolution, and companies have embraced that at the highest of levels. This is why, Amazon makes 16 billion bucks a year from this stuff. Because it's just easy, and right, and enterprises need things to be easy, efficient, and effective, and if they could just put all their data in one place, it becomes very easy.
Because of this, commercial cloud providers were entering a heyday of hyperscale growth and adoption. However, 5 years later, there is no single cloud. Instead, organizations are looking up and seeing a sky full of clouds, some public, some private, and many that are hybridized, and this number is only increasing. Some government customers require their software to run in purpose-built government or classified clouds that live separately from standard public cloud infrastructure. Such is the case with the U.S. government's FedRAMP and impact level accreditation programs. We've also seen stringent data protection regulations put in place by national governments, particularly in Europe with GDPR. This has resulted in enterprise software frequently needing to be hosted in-country. Simultaneously, large companies are increasingly moving to private clouds and returning to on-premise for security, data privacy, or financial reasons. Together, this cloud...
So basically what he's saying here, again, Palantir, the way they talk about things sometimes is a little complex. like the government can't trust the basic clouds that some of these other commercial clients use, which is going to probably sort of segue into Apollo.
Cloud fragmentation has narrowed the opportunities available to companies relying on traditional SaaS architecture. These companies are left to stagnate, unable to evolve alongside their customers or support robust product growth. To keep up with expanding delivery environments, some organizations decide to build continuous deployment capabilities in-house. While this is certainly possible, doing so pulls valuable resources away from innovation, as time is wasted cobbling together a set of open-source CI/CD tools that were designed for a singular cloud world. You need to keep your engineers spending their creative energy on building new capabilities for your customers, not figuring out how to deploy and operate those capabilities. You need an operational story for a disaggregated deployment model that doesn't require you to scale your headcount in order to scale your business. That's where Apollo comes in. Apollo is an orchestration engine for the enterprise, enabling continuous deployment, configuration management, and central software operations across these many cloud and on-prem environments. Apollo employs a number of different concurrent processes, including version management, advanced rollout strategies, and release promotion to ensure platforms stay up to date and operational 24/7. With Apollo, you can release new capabilities, deploy them at scale, compose them into novel platforms, de-risk releases, and rapidly resolve problems as they arise.
So the way I kind of understand this right now is that companies have lots of data stored in lots of different places when it comes to the public computing cloud infrastructure. And instead of hiring a bunch of engineers and having your headcount and having your engineers worrying about how to make sense of all of that coming together, in order to ship updates or to optimize that, Apollo is sort of this continuous infrastructure that maps across all of the different computing data centers that you may use, whether it's all different things in AWS or Google or Microsoft, and then tries to optimize everything that is integrated across sectors in one place through a centralized hub. And this is sort of the software that we're looking at, or the user interface that we're looking at, where if you want to ship out a new version number and you have to get all these different things in all these different places, how do you use Apollo to be this type of continuous system within the architecture of the infrastructure of all the data that is in various different parts of the public cloud, and then make sense of that, and then ultimately roll it out to the world.
Having deployment health and continuity on a single pane of glass gives engineers a common interface to handle risk management concerns unique to each environment. Here's how it works. Most software companies have already adopted containers and have a continuous integration pipeline for their software development lifecycle. Let's add Apollo. First, you define the capabilities and configuration of each service you want to run and package it into a distributable format, a standard OCI container image. This framework does not require you to make code changes. The Apollo Hub is the central environment containing the Apollo software catalog, orchestration engine, and control panel for managing your software installations across the environments in your fleet. Within this hub, you simply register new versions of your services. Your code and software always stay within the existing source control and artifact repositories.
So that's really important, right? So within the Apollo Hub, the stuff that, so as you see on this chart, right, you have AWS, then you have registry, and then you have your build system. AWS is where all your stuff is. That's where the software engineers and everyone is going to work on that. And they're going to work to make the software better, right? So the software development cycle of a product is going to be consistently changing, consistently be updated. New features are going to be added. That's all going to happen through the cloud on AWS. But in order for you to understand how to push that stuff and to make sure that stuff actually gets integrated into all the devices you want to shift and update in, or ultimately want to optimize and update across the sectors by which your data is being stored, that's where Apollo comes in. To me, it's more of a continuous system, again, built into the infrastructure, but that's in a centralized place so that software engineers don't have to do the dirty work of going everywhere, but kind of see it all happen on their screen. It's kind of like, it's kind of like Google Chrome almost to some extent. It's a browser, right? Instead of like opening up all these different websites, you go on Chrome and there's like usually your top 8 websites right there, right? That's your centralized hub of the stuff you need to access at once. That's what I think of Apollo Hub as the centralized hub of searching for software and making sense of software within the development cycle of an actual organization.
Next, there is a deployment platform that runs within each environment you want to deploy and manage software within. This is a set of software that sits on top of Kubernetes, but also supports a containerless world. The deployment platform within each environment connects back to the Apollo Hub, reporting the current state of the environment. It then receives updates to the target state of each service as upgrades or configuration changes become available and meet the constraints declared by both services and the environment. Apollo is built to power workflows at scale. So as you deploy to more environments, your engineers stay focused on shipping new capabilities and not the mechanics of how those capabilities get deployed or upgraded.
So that's a big thing right there, right? As you see on the video now, we have Azure, AWS. When you're working with a bunch of different softwares and a bunch of different sets of cloud computing softwares that have all those things you need, developers just want to ship updates, right? Like, so if I'm a developer and I'm shipping a new update to Facebook, and we've got some part of our messenger service in this part of the cloud and some part of our virtual reality part in this part of the cloud, but you want messenger to interact with virtual reality, you need very highly technical people to make sense of the code in messenger and the code in the virtual reality stuff, and you got to ship those updates. If you're using Apollo, that would be the centralized hub for developers from each of those different sectors, messenger and virtual reality, to then work together within the Apollo hub to make sense of what's being shipped so that they can ship, which means get the update out there, versus worrying about integrating.
Different environments have different risk tolerances when it comes to software updates. For instance, you'll want to roll out new features to canary environments first before moving those same updates to classified networks or to critical edge hardware that are harder to operate within. Apollo facilitates software stability across these different environments by using a concept called release channels. Environments can subscribe to a release channel in accordance with their individual risk tolerance and appetite for new features. Once pushed via release channel, Apollo enables the evaluation and rollouts through a powerful suite of tools to help operators understand the risks associated with each pipeline, surface problems, and ship code better. As new opportunities require your software to be deployed across new cloud regions, cloud providers, and on-prem environments, Apollo enables your business to deploy software where it's needed. Your software engineers can continue to focus on the product and not on building for specific environments. Managing incremental installations of software are treated no differently than your first development and production environments. Your software engineering teams rely on the same mechanics for how their software gets delivered. Apollo makes it possible to take the same approach to continuous delivery across different security or classification boundaries by enabling you to deploy an Apollo hub within each network boundary. Each network hub is responsible for managing the environments on that network. This compliance-aware change management enables Apollo to centrally manage services and environments across different compliance regimes, empowering seamless operations across highly regulated business environments. Apollo effectively removes the deployment environment as a constraint, enabling engineers to focus on velocity and application code. They write code once that works for all customer environments. Ultimately, this approach brings more capabilities to customers faster, supercharging your growth by bringing homogeny to an increasingly heterogeneous world.
All right, yeah, that last part, that's the important part, right? So like in a heterogeneous world where things are all complex and intricate and they're spread across a variety of mechanisms, for software devs, right, developers to work together to get new products out there, to get new features out there so your customers can get more innovation so that you can grow as a company, especially within a highly regulated business environment. When you're on the same page, it makes more sense, right? So the really cool thing about Apollo is, and it's a little bit hard to understand, right? And they should probably do a better job sort of explaining it, even though I think they tried their best with this type of software. It's just very complex. Is like there are a variety of different things that exist within an organization. And there's some stuff that's classified, some stuff that's commercial, et cetera, et cetera. All of these have different internal and external networks that are associated with the software, especially in high growth technology companies that need to constantly be updated and, have new features associated with them so that customers can enjoy those products. And in order for that to happen and in order for that to be integrated, developers have to work together. And in order for developers to work together, if there's a centralized hub and that controls the interface for how everything interacts with each other, and all those developers can connect and communicate in that one place to actually ship out software that integrates with every single part of the network, then you've got something that's more faster, efficient, effective, and ultimately gets the job done quicker, saves you money, and lets you grow even faster than you could imagine. So, I mean, it makes sense to me. It's pretty cool stuff. That is what Apollo is. I did a review on Gotham. Check that out. I'll leave that video up in the end card. And yeah, I mean, these are the three things that they offer. Foundry is really for commercial businesses and for governments to make sense of their data. Gotham is for governments to defend their stuff. And Apollo is for all organizations to have a centralized hub to understand how networks are interacting with each other. So those are the three services offered by Palantir. I hope this gave some more commentary. Let me know your thoughts in the comments of what you think about Apollo. My name's Amit, and I'll see you in the next one. Thanks for watching.